The discovery. On July 1, 2025, what began as a quiet and routine night at the Atlas Survey Telescope in Rio Hurtado, Chile, suddenly transformed into an event that would ripple across the world of astronomy. The night sky stretched vast and still, filled with countless stars and faint smudges of galaxies painted across the Milky Way. Yet amid this familiar tapestry, astronomers noticed something strange. A streak of light cutting across the darkness at a speed and angle no ordinary object should display. The instruments screamed with urgency, and alarms echoed through the observatory halls. At first, the team thought it might simply be another interstellar visitor. Another wandering body like Oumuamua or Borisov, cosmic drifters that had already passed through our solar system in years past. But within only a few hours, the truth became clear. This was no ordinary discovery. This was something humanity had never seen before. The object was quickly labeled 3I, Atlas. It was racing through space at nearly 60 kilometers per second. Faster than any natural body ever recorded at that distance from the Sun. That velocity alone would have made it remarkable. But then came the data that turned curiosity into something far more profound. This strange visitor was shedding pure nickel, 10 pounds of it every single second. Not nickel mixed with iron, as every meteorite and asteroid in our solar system contains. But pure, refined nickel, free of any contamination. Such chemical purity does not occur in nature. Not in asteroids, not in comets, not in any environment astronomers have ever studied. The question was immediate and staggering. Was this a bizarre and unknown quirk of cosmic chemistry? Or the first whisper of technology from beyond our solar system? As the discovery spread, observatories across the globe scrambled to respond. Teams began digging into their archives, desperate to see if they had unknowingly captured earlier traces of this object. Sure enough, the Zwicky Transient Facility revealed faint images. 3I, Atlas had been quietly crossing the sky for weeks before its official detection. Its faint streaks had been dismissed as background noise by automated systems. Only when scientists went back and reviewed the data did they realize what had been missed. Meanwhile, NASA's Transiting Exoplanet Survey satellite had caught glimpses of the object as well. Months earlier, when it was still beyond Jupiter's orbit, nearly 6 astronomical units from the Sun. What shocked astronomers most was that even in such a frozen, distant region, where comets are normally lifeless and inert, 3I, Atlas already possessed a glowing tail. When the Very Large Telescope in Chile turned its gaze toward the object, expectations were clear. Astronomers anticipated familiar signatures, water vapor, dust, and trace metals. But instead, the spectrum revealed something that left them stunned. Nickel. Streaming into the vacuum of space in staggering quantities. With no trace of iron at all. On Earth, separating nickel from iron requires immense amounts of energy. Sophisticated industrial processes. And yet here was a body in the cold of space, doing it effortlessly, as though it had been designed to do so. Then the James Webb Space Telescope joined the chase. Its sensitive instruments revealed a second anomaly. The ratio of carbon dioxide to water vapor in the object's tail was unlike anything ever recorded. In some measurements, carbon dioxide was nearly 80 times more abundant than water. A chemistry that defied every model of comets ever built. This isn't just unusual, said astronomer Adina Feinstein in her first published analysis. This is rewriting the rules of what interstellar objects can be. But chemistry was only half of the mystery. The orbit of 3I, Atlas was even more unsettling. Debate, consequences and the countdown. Rather than moving with the general flow of planets and comets, 3I, Atlas was traveling on a retrograde path. Moving against the direction of every planet it would pass. Astronomers compared it to a car barreling the wrong way down a crowded highway, dodging traffic at impossible speeds. Predictions showed it would swing dangerously close to Venus in September, graze past Mars in November, and by January 2026, skirt the edge of Jupiter's vast gravitational domain. The probability of a random interstellar object threading such a sequence of planetary encounters? Less than 1 in 20,000. A cosmic coincidence bordering on the impossible. Theories multiplied at lightning speed. Some researchers, including Harvard astrophysicist Avi Loeb, argued that the selective nickel release might represent a technosignature. Possible evidence of artificial engineering. Perhaps even a probe. Self-replicating. Or carrying some kind of message across the stars. Others urged caution, reminding the world that extraordinary claims require extraordinary proof. Publicly, NASA insisted on restraint. The message was clear: follow the data, not speculation. But behind the scenes, many scientists admitted the stakes. If there was even the slightest chance 3I, Atlas was engineered, ignoring it would mean turning away from humanity's first contact with alien technology. Time, however, was running short. By December 2025, the object would slip behind the Sun. From Earth's perspective, it would vanish, invisible to telescopes for months. Every observatory capable of tracking it was pressed into service. Teams worked in shifts, 24 hours a day. Analyzing spectra. Measuring brightness. Refining trajectory models with each passing night. Every photon captured was treated like a vital clue to an unfolding cosmic riddle. Comparisons to earlier interstellar visitors came quickly. Oumuamua in 2017 had sparked furious debate with its odd shape and unexplained acceleration. Borisov in 2019 stunned scientists with its pristine cometary features. But 3I, Atlas overshadowed both in its strangeness. Never before had astronomers seen an object with such chemical purity, such improbable orbital behavior, and such unnerving precision in its planetary encounters. Speculation surged into the public sphere. Could this be the remnant of a supernova? A fragment of exotic astrophysics we had yet to imagine? Or was it something more deliberate, a constructed artifact, evidence of intelligence beyond our own? Observatories buzzed like hives. Slack channels and email threads filled with arguments over probabilities, chemical ratios, and orbital mechanics. The public too followed every update with breathless anticipation. Newspapers speculated openly about alien technology. Meanwhile, official press releases tried to strike a careful balance between wonder and caution. As September drew closer, attention turned to the first great milestone, the Venus flyby. Would the planet's gravity alter the object's course? Would bursts of gas or nickel erupt from its surface? Each planetary pass promised fresh answers. Or deeper mysteries. But everyone knew the ultimate deadline. December. When 3I, Atlas would vanish behind the sun's glare. Perhaps forever. In the end, one truth became undeniable. Whether 3I, Atlas was a cosmic accident, a fragment of some distant stellar catastrophe, or a probe from an advanced intelligence, it had already changed astronomy forever. It reminded us that the universe is not fully mapped. That surprises still streak across our skies. And that humanity may not be mere observers of the cosmos, but participants in a far greater story, written across the stars. And as this drama continues to unfold, one thing remains certain. The countdown has